Record. So study set 2. So you all hopefully uploaded your study set. Again, study sets are due at 6, and then the worksheets are due by midnight. And again, you can turn, I'm videotaping, so you can turn your camera off or you can leave it on because nobody but us watches this videotape. 2 quick comments for all of you. One is something actually Philip reminded me of today. For especially those of you who are new to me, on your, I make comments often on your assignments. So I think on everybody's lab, I wrote a comment to you. And so if you go, once it's graded, if you go into your grade book, I don't know if a flag or something comes up, but you can see my comments. And on the worksheets, I actually, if you didn't like come to an office hour and have me check it, if you had a mistake, I wrote a comment, and sometimes I will try and scribble on your worksheet. My handwriting's not great, so if you can't read it, just come and ask during an office hour. The other comment I want to make is about the second lab. I did post it today. That's what I forgot to do. There is a video that goes with it, and I am going to be traveling this weekend, so I will not be available for office hours. And so it's a lab where you won't need to come to office hours on Saturday to ask questions. You're going to pick 2 things. There's like a choice of like 5 or 6, and like could be an innovation, not a water innovation. This is like a air pollution or something. I did want to mention though, one of them is diet, and so it's a 7 days. And so you may want to look at it. So it's a G-bombs. Those of you who had me before, you may have seen this one. You've seen some of these before. These are a little bit different from last time. Oh, geez, I was going to wait till after class because I knew I had another idea, but that's all right. So if you decide you want to do the G-bombs and it's 7 days, just tell me when you submit your lab that you're still working on it. Tell me how it's going, and then you'll just have to like update me at the end of the 7 days how that challenge went. So there's 2 challenges that you get to pick within the lab, or things to do. Like there's some art that you can do, choices. So some of you enjoy the art ones. And all right, let's go ahead and go through this. So I talked about this last time. We can get 7 atoms 2 different ways. So one way is to just count straight across 1, 2, 3, 4, 5, 6, 7. In this example, going straight across 7, it's 7. It doesn't matter which way you number because the methyl will be at 2 and 6, and this propyl will be in the middle either way. So going that way, if we named it, would be 2,6-dimethyl. This is the right way to name it. 2,6-dimethyl 4-propyl. I wanted to mention the propyl. So this is propyl because it's 3 in a row. That's not part of our longest chain. There is another way to do this one, and that would be, and again, it doesn't matter. This is actually symmetrical, but if you started here, over here on the right, and go backwards, it would give you the same. But we can do 7 going this way, and that would be heptane again. This piece here, that is an isobutyl. So that is 4-isobutyl. If we named it, this one's the wrong one, 2-methyl heptane. And it didn't say you had to name both ways. My blue one is the incorrect one. Does anybody know why why the pink one is correct and why the blue one is wrong? This happens very, very infrequently, and if it does happen, it was not necessarily on purpose. I often, when I make the pictures, I just make pictures, but on the homework question it was. You always want to go the longest chain, but if you get 2 ways you can get the longest chain, you go the way that you get more side groups. So smaller side groups are easier to name, so we want to go the direction. Here we get 3 side groups, so methyl, methyl, and a propyl. Here we get 1 big side group. And it might seem like it's easier to name the big side group. That's because it's only a butyl side group. All right, so number 2, the nomes. These are fun questions. So pentane, you can make your sketch. And if you put the ethyl at number 2, your longest chain is now 6. So 1, 2, 3, 4, 5, 6. So at 3, we have a methyl and hexane. So colors are wonderful, erasable colors. All right, pentane again. So 1, 2, 3, 4, 5, and then 3, 3, and 4 have a methyl. So my longest chain is 5, but we would want a number in the opposite direction. So it's simply the same name, but it would be a 2,3,3, trimethylpentane. So sometimes what's wrong with the name is actually quite simple. All right, on the next one, when you draw it, your hexane, and again, you can draw this with carbons. At number 4, we have an ethyl, and at number 3, we have a methyl. And so the hardest part on this, it is still hexane. No matter how you draw it, these guys are at 3 and 4, the methyl and ethyl. So if the side groups come out at the same number either direction, the alphabet takes preference. And so this would have to be that it was a 3 ethyl and a 4 methyl. So the name should have been 3 ethyl, 4 methyl hexane. All right, and then the next one, you can make a quick sketch to make sure, but you have an ethyl at 3 and ethyl at 4, which is what it's going to be. And the ethyls have to be combined. So it's a 3,4 diethyl hexane. I like the zigzags because they're just because visually for me, I see them better, but you can also write it out with the carbons. I recommend if you like writing in the carbons, it's usually about a 50-50 mix. On these, you can leave the hydrogens off, so you're just seeing the backbone. That can make it easier to do, but this would be our 1, 2, 3, 4, 5, 6. Any questions? I just keep going unless somebody has a question. All right, and then we get to the isomer questions, and that's what the study set is that you just need practice. You need to try it, because then you suddenly are like, oh, I don't know what she's doing here. And then, so isomers mean they are the same formula. So the number of carbons are the same. The molecular formula is the same. That is what an isomer is. Same carbons, hydrogens, everything else. The density is going to be different because they're going to be stacking different. They're going to fit together different. The shape is going to be different. The name is going to be different. All right, and then the force. You can do these a couple different ways. For A and B, they come out the same. The two molecules are the same. So if you figure out this is 1, 2, 3, 4, and there's a methyl there at number 2, if they come out with the exact same name, which this did, they were butanes with a methyl at number 2, they're the exact same molecule. This is the same thing. All I did is flip it. So you can, this is something, Vincent, we were talking about beforehand. If you're ever stuck, name both of the molecules. If you come out with the same name, they're the same. But you can eventually hopefully get to a point where you can just do the numbers maybe and see, okay, I have a 2-methylbutane without having to write the name out. And this again would be a 2-methylbutane. These first two are nice because it's showing you the same molecule drawn 3 different ways. All right, on C, we have isomers. So one of the things you want to make sure is that you have the same number of carbons. So I have 4, 5, 6. So we have 1, 2, 3, 4, 5, and the 6th one. And then this one is 1, 2, 3, 4, and then 5, 6. So this is a dimethylbutane and a 3-methylpentane. So they're isomers. They have the same carbons, same molecular formula would be that they're both C5H12. Yeah. All right, the next one, they're not related. If you count your carbons, 1, 2, 3, 4, 5, 6, this has 6 carbons, and this one has 5 carbons. So they're unrelated. The carbons are different. These are always tough questions for students, and that's why they're all over the study set, because it just takes practice. I highly recommend that sometime in the next couple of weeks that you redo your study sets and then go back and hopefully you have your answer key, or you can always go back and rewatch the videos. All right, the next one, for me, these I can just look at and see if they're the same or isomers, but you can do the same thing. You can count 1, 2, 3, 4, 5, and then we have a methyl, and this would be 1, 2, 3, 4. So we have 6 carbons, so they both have 6 carbons, but they're arranged different. So these are isomers. On this one, 1, 2, 3, 4, 5. So this has 7 carbons. And this would be 1, 2, 3, 4, 5. And look at that, they came out exactly the same. It's just bent in different ways. So these zigzags are really nice because organic molecules are not static. Like, we look at them on these pieces of paper and we think that's what they look like, but they're always twisting around. Single bonds are always twisting and moving around. These are both the exact same thing. So just numbering them can really help you. They both have 7 carbons. They're both 2,3-dimethyl pentanes, so they come out the same. On this next day, these are isomers again. So they both, again, have 5 carbons. Again, you don't have to number, but it's something visually that will help. So they both have 5 carbons. This is a 2,3. This is a 3,3-dimethyl. Sorry. So they both have 7 carbons total, rearranged. All right. And the next one, finding your longest chain. 1, 2, 3. So this is a question 4, 5, 6. Somebody asked me in office hours, I think it was you, Allie, you would start numbering this one if you did it correctly, starting down here, because you run into the side group, maybe it was you, Haley, of ethyl at number 3. If you start here, 1, 2, 3, you run into the methyl at number 3. So the alphabet takes preference. All right, 6, 7, 8, 9. This has 9 carbons. And we have an ethyl and a methyl. This one, doesn't matter. You get 1, 2, I numbered backwards, sorry. 1, 2, 3, 4, 5, 6. And then we have 7, 8, 9. So we have 9 carbons. This one, right, they both had 9 carbons. This one had a methyl at 2 and an ethyl at 4. And these are at different places. So that is an isomer. So again, for some of you, you don't have to do the full name. You can just do numbers and then realize what the pieces are, counting your carbons. Go back and redo these and see that, yeah, it's usually during this week that it starts clicking, because we just get immersed in this. And next week, a quick reminder, Monday next week is a holiday. So we don't have class. Hooray. All right. Isobutyl. This is a really nice question. I'm sorry. I have isobutyl. So it's 4 carbons making a T. This is a tert-butyl, or most people just say T-butyl. I do want to remind you, isobutyl does start with the letter I. It's one word. T-butyl actually starts with the letter B because it's hyphenated. So when we get into the naming, that becomes important. And same with sec-butyl. It is hyphenated, so it starts with a B. So it's sec-butyl because it's 4 in a row and it's attached to the second. And then this is isopropyl. The line is just representing that you'd have a really long chain of like 10 carbons or something. All right, cyclos. A is just cyclopentane. So pentagon. Probably the biggest mistake I see with cyclos is just forgetting that name cyclo in front of it. Right, this is a cyclobutane because it's 4 is butane, and that's a methyl. So with cyclos, if there is only one side group, you don't number it. It's at number 1. We don't put the number. However, on C, you do have to tell me those methyls are both at number 1 because there are 2 side groups, meaning 2 methyls. So it's a 1,1 dimethyl and then cyclopropane. And then our last one is a 1,4. It doesn't matter which one you give the number 1 to. It doesn't matter which direction you number in because they're straight across from each other. It's a 1,4 dimethyl. Remember if there's 2 to put that di there. And then cyclohexane. Any questions on this first page? Anything need me to go back over? All right. Let's go to this page. All right. So, I didn't talk about fractional distillation. That's a wonderful word. Distillation just means separation via boiling point, not blood pressure, but boiling point. And so if you ever, like when I'm taking the train across country on Saturday, when I'm not in my office hours and I go through North Dakota, there's so much fracking going on there. And then the separation of what they're pulling out of the ground. So you're getting a mix of hexane, octane, methane, all sorts of stuff. And then they separate it based on boiling point. All right. Higher boiling points. Surface area. The higher the surface area, the higher the boiling point. That is why, that's our explanation for every single one of these is higher surface area. So more carbons. You can just say greater surface area, or you can say more carbons. All right, these guys both have 4 carbons. So you're looking at the one that has fewer branches. You only look at that if they have the same carbons. So the butane, because it's going to have more surface area, more areas for contact. And then the last one, same thing, it's a pentane because there's fewer branches. You have more surface area, it's zigzagging. With the propane, they both have 5 carbons, and so more surface area for that one. All right, so that was the question somebody in office hours had asked about the boiling point, and that's what it is. We're going to see this become, as we add today after going through the study set, we're going to start adding double bonds and triple bonds. And then after our first celebration, we start getting into oxygens, and so this just becomes more elegant. Let's just move on. So we get to do combustion. Butane is 4 carbons and double the hydrogens and add 2. So C4H10. And combustion means we always react with O2. So all organic compounds go through combustion. This is one of the placards, the fire placard you'll see on trucks. And anytime they have an organic compound in there, it catches on fire. So it burns. That's all combustion means, is if there's oxygen, and that's what's in our atmosphere, and we get CO2 and H2O. And that CO2 is, of course, a problem. For balancing, 4 carbons become 4 CO2s, 10 hydrogens become 5 H2Os. And then you can do this one of 2 ways. If you don't like the first way I'm going to do it, which is the fraction, you have 8 plus 5, so we have 13 oxygens. So you can do 13 halves or 6.5 O2s, because that will give you 13 oxygens. So this is back to things from 104. It's the big point of question 10 is to just know that all organic compounds will burn. If you don't like the fraction, then you just double everything. So we would say 2, 13, 8, and 10. So we have 8 carbons and 20 hydrogens. So here we have 8 carbons and 20 hydrogens, and we now have 16 plus 10, so 26 oxygens. All right, question number 11. So just a quick comment, because a lot of you are, half of you are new to me. I will sometimes write this note, sometimes I forget, but there are almost, well, occasionally, probably almost always, a question that will show up on the study set that I know I didn't cover in class, because I know there is a point where our brains are full, including your teachers, where my mouth is just tired of talking and hearing my own voice. So reactivity. Alkanes are very stable. That is why they are fossil fuels. They are the most ordinary, and that makes them extremely beautiful. There's no double bonds. We're going to get into double and triple bonds in about 15 minutes. Double and triple bonds are highly reactive. There's no oxygen or nitrogen. That makes things reactive. These guys are single bonds, just carbons and hydrogens, just hanging out. It's what everything reacts and eventually will become. However, so this does not happen in nature. What happens, let's take propane. All right, so 3 carbons, and you can write it as a zigzag, or you can write it, we can write it showing our carbons with our hydrogens. I'm going to actually show it this way because that will be easier. And we're going to add bromine, so Br2. So that's what it means to, yeah. And I don't know what has happened to my Zoom. I wonder, oh, there we go. I've been trying to figure this out. So now when I record, it will actually show my face. So I apologize. I couldn't figure out why it had changed, and I pushed a button. Buttons are awesome. All right. So the key word here is mono. So this, the only thing they can get alkanes to react with are halogens. And what happens here is called substitution. So we're going to take a hydrogen, and it's going to switch places with the bromine, with one of the bromines. So you're going to end up with your 3 carbons, and now a bromine is here, and the other bromine has the hydrogen. So back in chemistry 104, these were the swapping kind of reactions. So substitution is a swap. It is always only one piece switches positions, so only one hydrogen. Now, the thing that's a little bit crazy about this, they have to do insane conditions to get this, like extremely high heat and pressure, I think, and other things. And so it doesn't happen under normal conditions. I was really good at organic chemistry because I'm very visual, but the reactions, this reaction is just silly because it's not natural. The reason I'm drawing a second one is the bromine, actually, you can't control where the bromine goes in a substitution reaction. So the bromine could go also there to the second carbon. So here we go, first chance for a bonus. We can put it at number 1. We can put it at number 2. What about putting it at number 3? Would that be something else? Maybe.
No, it'd be the same because you can name it from left to right, or
Yes.
either way.
Is that Ezra?
Yeah.
Okay. Yeah, so you got it. That you could if it was at 1 bromo is the same as 3 bromo. So a 1 bromo propane and a 3 bromo propane are the exact same thing. So you get a mix of products. All right, let's move on. That's enough. We'll talk about reactivity more. I think Wednesday's lecture, we'll talk about reactivity. All right, we're back to the nomes. So cyclopropane, when you draw these, do be careful of cyclos. Yeah, even your teacher will miss this. So the problem is there's 2 methyls. We need numbers. The other problem is the nomes didn't tell us where the methyls are. So you have a choice. You could put them both at number 1. You could put them next door to each other. So you either could do a 1,2 or a 1,1 dimethyl. Either answer is fine. You don't have to give me both. Cyclopropane. It is, you have to, if there are 2 side groups, even if they're at the same position, they have to get a number. You cannot have a 2,2 because then you did a nome name. You have to have, something has to be at number 1 in a cyclo. All right, and then, so what's the mistake for B? Anybody see the mistake?
You don't have to say that. You don't
Go
have
ahead,
to.
Jeremy.
You
Why?
don't have to list the 1 because you know that there's only 1 methyl, so it starts at 1.
Yes, in a cyclo. So that is only true for a cyclo. So if there's 2, you have to say where they're at. If there's only 1, you do not say the 1. All right, and then this one makes absolutely no sense at all. Cyclobutane, there's only 4 carbons, so what are they doing? So they're saying 2, 3, 4, 5. I don't know. I've had people give me, as long as I get 1, 2 dimethyl, you can't have a 5 in a butane because there's not 5 carbons. I have also had, so dimethyl cyclobutane, that's how I name it. The gnomes and I have frequent conversations. I have this thing about gnomes because a student 10 years ago told me I had laryngitis. I couldn't speak at all. Told me I sounded like a gnome. And I just, first of all, I mean, that's kind of a weird thing to say to a teacher or to anyone. But my thought was, how do you know what a gnome sounds like? But I have also had students decide that it's a 1,3 dimethyl cyclopentane. So I mentioned that because there's probably 1 or 2 of you who did that. You do not need to give me 2 answers on these. Just pick 1. Did anybody come up with something different?
I did 2,4 dimethylbutane.
So you have to, in a cyclo, you have to have something at number 1. So you would have, yeah. So if you did 1,3, I would probably give you that. Sure, they're just naming them funky. But yeah, you have to have something at number 1 in a cyclo. All right, so we're back to the isomers. So again, some people do great with the pictures, some people like the carbons, and some people, the names, they just rock them. This one, they are unrelated because they have different number of carbons. So we have 6 carbons versus 7 carbons. So they're just different. On B, they are isomers. So 6 carbons and 6 carbons. So butane is 4 plus methyl is 6. On D and on C, both of these are unrelated for the same reason. So anybody want to tell me why these are unrelated?
The hydrogens are different.
Yeah, why? How do you know from just looking at the names?
The cyclos.
Keep going.
Well, one of them is a hexane and one of them is a cyclopentane. So for one, since it's a pentane, it's already smaller, and cyclo removes even more.
Well, actually, it would have a methyl there.
Oh, yeah.
So what happens on, sorry, I don't know who that was who answered, sorry.
Bianca.
Bianca, thank you. So what I was going for fully, Bianca, was that when you make it into the cyclo, you lose those extra hydrogens. So when it's a regular alkane, you take the number of carbons and then you double the hydrogens and you add 2. So the ends always have an extra hydrogen. But when it's a cycloalkane, and this is, I'm sure what you're trying to say, but you know, you don't have 25 years of teaching the experience. Every hydrogen just is double, but since you closed it off, there's no N, so there's no +2. So these are not actually related. We teach them in the same chapter because they're all single bonds. So they're both considered saturated, but she is correct that they are unrelated because the hydrogens are different. So different hydrogens. Yeah. All right. Molecular formulas. Philip, this was, I knew when I saw you, I was like, there was something I wanted to comment. So on the lab, the bonus question was really tough. I was trying to see if I had my picture. I'll show you on these. There's a way, because we might run into one of those again. There was somebody who got it, who actually got it. And the mistake you made, Philip, and I didn't add yours up, is when it wants molecular formula, you're just telling me carbons and hydrogens. You're simplifying it down to how many carbons, how many hydrogens, how many oxygens. So if we have 18 carbons, we double and add 2, so 38. So that's what I was looking for. 7 carbon, but it's a cyclo. So 7 carbon, we just double. So that's back to what I was talking about there. All right, this question. This is an alkane. So they will often call them acyclic. So that prefix, we saw that somewhere on here. That prefix with the A means not a cyclo. So in case you run into that, this one is a cycloalkane. Right, so we got those 2 choices. Halogenated means they have a halogen. So the halogens will always, back to this monobromination, they will replace a hydrogen. So we're with the same rule that, like here, we doubled the hydrogens and then we added 2. So this is the halogenated. So we'll just say halo. We could do the if we did it. So whenever you see the halos, the halogenated, that would be weird with this because halogens are extremely toxic. And so I guess that would be almost morbid to start singing like the angel there. But these are the halo alkanes. And this one, if I add the 10 and the 2, it is a straight doubling. So it's a halo cycloalkane. And I'm imagining a couple of you are at least doing that muted behind me. We did these angel thing last term. All right. So I did promise a quick comment. If pretend I asked you to count all these carbons here, you can, since it's a regular one, you can count, right? You have 1, 2, 3, 4. Well, we have to count them anyway. I'm thinking this is our 1, 2, 3, 4, 5, 6, 7, 8, 9. We have a methyl, and then this is a propyl coming off here. So this one, 1, 2, 3, 4. If I started here, I get to 9 also. But again, it's the way I numbered in the blue because you go the direction in which you get the longest chain while also breaking it into more small side groups. Yeah, that wasn't, I guess I'll show it on that. I was trying to show you how to do that bonus on the lab, and this wasn't a good example. So 2 methyls, So, and the propyl. So the methyl comes first. So 2,3-dimethyl. Somebody asked me last week, do you have to write the M's and the P's? No, I do that often because as we get to more complicated ones, it helps me alphabetically to get it right. So since I don't have an eraser and I'm videotaping myself, and this would technically all run in together. So 2,3-dimethyl, 4-propyl, no name. All right, this one. 1, 2, 3, 4, 5, 6. So we want this methyl group to be at the lowest number possible. So it's just the 3-methylhexane. And then these guys are cyclos. The side groups have to be at 1. So one in side groups is at 1, and the other one has to be at the lowest number possible. So you can number clockwise or counterclockwise. You just need the side groups at the lowest numbers possible. These are ethyls. So it's a 1,2-diethyl cyclohexane. And then I just love these pictures. Let's do this, guys. So this is propyl, the little legs. It looks like one of those little eater bugs. And that's an isopropyl. Alphabetically, I comes first, so that gets to be number 1. And then it doesn't matter which way we number. This will be at 3, this will be at 5. So we have to say the 1 for the isopropyl. Once there's more than one side group, they have to get numbers in a cyclo. And then 3,5-dipropyl. So I'm giggling because this is like, it's kind of a silly game that we're playing because you're really not going to have to name any of you, including myself, in our life. We're never going to have to do this, right? But it actually is this amazing thing that happens that when you can start naming them, you can view them totally different. And it's actually really calming. It's almost like those coloring books and stuff that we all do. And so it's just naming these and finding them. And so seeing it as a puzzle and approaching it that way. And that's why I said, we're not going to call them exams or quizzes. We're calling them celebrations because it's a celebration to see what pictures, what names we can come out of from these pictures. This is a good one for trying to figure out how many carbons. So we have 6. And then you would have to count, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'd have 9 on the outside, 6 in the center. So 9 plus 6 is 15. And then you'd have to figure out how many hydrogens you have. And so what I did is I just put numbers that I have 3 hydrogens, 2 hydrogens, 3 hydrogens. Here I have 3, 2, 2. Same here. And then I counted up all my numbers. And so at every corner, you have to have 2, but like these corners would only have 1. No. Or you can write all your hydrogens in, but I don't even know how to count that. 2, 3, 6, 9, 12, 15, 20, 24. It doesn't make sense. It's an H31. All right. I'm not sure if I counted right. All right. I'm going to stop sharing unless somebody has a question. I'm going to stop recording. Go ahead.
So how did you, what did you end up with for 16A?
1,2-diethyl.
1, 2, okay. I just didn't understand that because I was trying to count from a different side.
You see it now? Do you see it now, Kaylee?
I do.
Okay.
Yeah. It couldn't be it couldn't be a octane?
No.
No. Okay.
So that's
That
I
makes
see where you're going, but it's the cyclos there and these are sticking off of it. So you don't, when it's a cyclo, you're not trying to get the longest chain. The cyclo is the
It's
piece.
close and that's it.
Yeah.
Okay.
So with that, we're going to be changing some of these rules in about 1 minute here as we move into the unsaturated. Anybody else have a question?
For
on these.
13B, I have a question.
Yeah.
So I can see how they have the same number of carbons, but don't they have different number of hydrogens?
No, because they're both an alkane. So unless we made one into a cyclo, closed it off. Yeah. So that's why, like, you're okay, Philip, why C and D are not related, because the cyclo, it changes the hydrogens. This one, there's not a cyclo. We didn't make a double bond. So they're going to be the same. That's the best I can. Yeah, you can look at that. It's a good question. Anybody else?